Hi. When I said success, following with Kumar for success, I meant that you do my work, listen to me, and over maths, alright? And if you're not clear, rewind and find out which is the part. And as you follow through again, it becomes clearer. Now let's look at a simple example of tossing a coin. You toss the coin head or a tail. Now there are two outcomes here. You get a head or a tail. Now if it is a fair coin, that means the chance of getting a head is 1 out of 2, right? But in the tail, it's 1 out of 2. But if it is a biased coin, all right, a biased coin, that means the coin is not very fair in its outcome. It's heavier on the head maybe, or heavier on the tail, the way it's being made. So when you roll the coin, the chance of getting a head is maybe more than that of a tail. So you cannot divide it. That's when we use the word bias, show favoritism. You know what I mean? Not very nice quality, right? So not to be biased. But let's look at this biased coin. All right? The probability of getting a head is 5/8. And so, what is the probability of getting a tail? The probability should be 1 whole. So 5/8 in getting a head. So the tail should be 3/8. Great. That is the first part. I throw a coin, I got a head. When I get a head, I throw again. This is the second chart. I can get a head or I can get a tail. What's the chance of getting a head? 5/8. What about a tail? 3/8. I throw again. If I had got a tail, the first time I throw, tail. Now I follow this event. Now I get a head or a tail. What's the chance? A tail is 3/8. I throw it again, a head is 5/8. How about a tail again? 3/8. So now, my dear friends, this is actually, this path is a head. This is a head-tail. This path here is a tail followed by a head. And here the event is a tail. This is what we call an independent event. Alright? I can't say they're mutually exclusive, not at all. It's an independent event. Now you throw here, you get this. This outcome does not depend on this, but alright, you get a head. And then the second one you throw again, you get either a head or a tail. But if I want a head followed by head, then you can see these two, I must take this path. So that's the independent event here, a head followed by a head. So what is the probability of a head followed by a tail? A head followed by a tail. So the first event is a head, which is 5/8. The tail is 3/8. And you multiply the two. You get 15 out of 64. Take note. Now what happens if I said, hey, I want the probability of 2 heads. A head followed by a head. So you said, no problem. What's a head followed by a head? A head is 5/8. The second head is again 5/8. There's no replacement. You've got one coin, a head. Throw the same coin again, a head. So this outcome and this outcome, a head followed by a head, is 25 out of 64. Now, I'm not going to look at this. This is third level. But I'm going to ask you what happens if I want 1 head and 1 tail. Alright, let's move to that first. The probability of 1 head and 1 tail in 2 outcomes. Alright, 2 times that you throw. It can be a probability of a head, tail, right? Plus, it can be a probability of a tail, head. A probability of a head, tail, and then a tail, head. So we look at the head, tail. Look at this path. That's a head tail. And a tail head is this path. So if you look at the probability tree, this is what you call a probability tree. So a probability of a head tail, a head appearing is 5/8 times a tail appearing is 3/8. You've got that. And then here, the probability of a tail appearing is 3/8 and a head appearing is 5/8. Now these two events, you call them mutually exclusive. Alright, this one event, and then they take this event and this other event. They're both mutually exclusive, so you're adding them up. Because you said, I want one head and one tail from my two outcomes. So whether it's a head tail or a tail head, that's what it meant. I don't want a head head, I don't want a tail tail. That's what it means. So if you add them up here, you get 15 out of 64. And here you get 15 out of 64. And that gives you 30 out of 64. 30 out of 64. Let's go a little deeper, my dear friends. When I said I want a probability of one head and one tail and one tail, alright, and one tail from my two outcomes. I'm not specifying the order of the event. I'm not saying I want a head followed by a tail. There is a difference here. I want a head followed by tail. It's only 15 out of 64. But when I said I want one head and one tail from the two throws, the chances doubles up. It's 30 out of 64. Now I want to look at it in another way. I want one head and one tail from two throws. So the chance of definitely the event happening will be one whole minus the probability of two heads and minus the probability of two tails. Let's look at that. One whole, probability of two heads is 5/8 times 5/8, and the probability of two tails is 3/8 times 3/8. You get one whole, which is 25 over 64, 9 over 64. And you can see when you add these two up, you get 34. One whole minus 34 out of 64 gives us a chance of 30 out of 64. Aren't they the same? So that's what we're trying to prove when they said we want one head, one tail. Alright? It's a one definite, a surety, minus as long as we don't get this and we don't get that, we will get a head and a tail. One head, one tail. Alright? Like what we did here. Is it clearer now? I see you smile at me. Great. Now let's move on to the third one, the third stage. Let's look at that. I've had thrown a head and a head. I throw again and I get a head followed by a tail. What's the probability of getting a head? 5/8. What is the probability of getting a tail? 3/8. Look at the total outcome when we add both of them. We get 8/8, which is one whole. Now look at the second one, the second part. I throw a coin. This is a head and a tail. And I throw again, and I get a head and a tail. So what's the probability of getting a head? 5/8. And how about a tail? 3/8. This is another pattern. So let's look at it and analyze further. Let's see what we get. In this case, we get a head, head, head. This is the pattern. A head, head, head. How about this tree, this part of the tree? It's a head, followed by a tail. Let's look at the green part of it. It's a head, a tail, and a head. That's the order of the event. We had a head first, then we had a tail, and then we had a head. If you go this way, it's a head, a tail, a tail. Now, if I were to go on and I said, all right, first is a head, tail, sorry. You got a head, and then you've got a head and a tail. Look at this here, tail, head, head. And how about here? Tail, head, tail. That's the order. Alright? And the probability of getting a head is 5/8. And the probability of getting a tail is 3/8. And the last segment, if I were to do here, this is a tail by a tail. And I throw it again. And I said, ooh, ooh. I got a head and a tail. And what is this here? 5/8, 3/8. So what is this path here? A tail, and a head. A tail, and a head. What is this path here? A tail, tail, tail. Got it? All right, good. Now, my dear friends, we get back to this sum. Now, they want the probability of a head, head, tail. That means they're telling you we want the first one to be a head, the second one to be a head, the third one to be a tail. Fine. What's the probability of getting a head? 5/8. What is the second head? 5/8. And what about the tail now? It is 3/8. So this is what we call an independent event. All right, we're multiplying them up. 5 times 5, 25, times 3, 75 over 5, 1, 2. Now, I'd just like to tell you that you can throw the coins 512 times, the total number of outcomes. Throw it, throw it, throw it, throw it. Now, from the 512 times, 75 times, you will get a HHT, 75 times. So you're going to throw. Then you get 75 out of 5, 1, 2 will be this outcome. Now, if we look at 2 heads and 1 tail, it is different. When you look at 2 heads and 1 tail, what does it look for? Look at the details. You want 2 heads and 1 tail from 3 throws. Here is 3 heads. Here is 2 heads and 1 tail. Here is 2 heads and 1 tail. Here's 1 head and 2 tails. No. 1 tail and 2 heads. You can. Here is 2 tails. We want 2 heads and 1 tail. Alright? So here in these 3 outcomes, you have 2 heads and 1 tail. Here is all 1 head. And here, no head. Alright? So the probability of getting 2 heads and 1 tail is the probability of getting a HHT. Look at that. Plus the probability of a HTH. Plus the probability of a THH. A THH. So what we've got is we've got 3 mutually exclusive events. And we're going to add them up. Mutually exclusive, we add them. This is 1 event. This is another way. This is another way of getting it. So 3 different ways of getting it. So 3 mutually exclusive ways. Right? This is 1 event. Dum 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 dum. Head, head, head. Head, head, tail. 1 way of getting it. Another one. Head, tail, head. That's another possibility. So you don't want to write it off. Alright? And then the other one, tail, head, head. So unlike this is telling you, I want a head, I want a head, and I want a tail. So whereas this is got a better chance than that, because you've got a head, head, tail, a head, tail, head, and a tail, head, head. So when you work it out, 5/8, 5/8 times 3/8, you've got a 75 over a 512. Similarly here, 5/8 times 3/8 times 5/8 will give us a 75 over a 512. Similarly, a tail, head, head, 3/8 times 5/8 times 5/8, you get a 75 over 512. So the chance of getting 2 heads and 1 tail, whatever the order is a lot more better, right? So you can see 75, 75, 75, 3 sets of 75 is 225 over 5, 1, 2. Ooh, much better chance than that. Alright, because we're not restraining it. We can say there are 3 mutually exclusive events taking place. So there's a greater chance you add them up. Alright, now, got it? Are you clearer now? Now I just want to be a little bit more, like here, if you want 2 heads and 1 tail, you can look at all the options, 1 whole minus all the others. If you take 1 whole, minus this, minus this, minus this, minus this, minus this, will also give us that answer of getting 2 heads and 1 tail. Because the total outcome of all these add up to 1 whole. You can find out, you can try it as in, if you have a time, work this out here, every one of them you work it out. Add the total probability and you must get a 1. The total outcome will be 1. Alright? Now what happens if they tell you, if I throw the coin 10 times and I want 10 heads, what is the chance of getting 10 heads from the 10 throws? So what do you get? Probability of head, 10 heads. Alright? So that means 5, 8 to the power of 10. So the probability of getting 10 heads, alright? 10 heads, head, 10 times. Alright? I put 10 heads times 10. I'm not going to repeat that. So it is 5, 8 times 5, 8 times 5, 8 times 5, 8. That means this probability is the power of 10. Okay? And what is the probability if I said I want head n times? So the probability of getting a head n times, alright, is actually 5, 8, you multiply it n times. You got it? Ah, great. 5, 8, multiply it n times. So what's the probability similarly of getting a tail n times? Alright? Okay, before I go into that, what's the probability of getting 3 tails? Tail. And let me put a forked tail, t to the power 4. The probability of getting a tail is 3, 8, 3, 8, 3, 8, 3, 8, power of 4. So that's what you write. 3 to the power 4, power of indices. I'm just getting you to jolt your memory on indices. Do you recall it? 3 to the power 4, 81. Great. 8 to the power 4, 8 to the power 1, 8, 8 to the power 2, 64, 8 to the power 3, 64 times 8, 5, 1, 2, and 8 to the power of 4 is 4096. Right? Now, so this is what we get, the probability of getting, alright, 4 tails. Now, we just used a simple example. My dear girls, if you are with me, boys, just listen. There are some husbands who are very mean and they tell their wives, my dear sweetheart, I want 5 sons. And your wife will blink. The poor girl. Guys, you be careful. If the chance of getting a son and a daughter is equal, 1 out of 2, the chance of getting a son for a girl is 1 out of 2. Some girls, both the chances of getting a girl is stronger. But if it's example 1 out of 2, you want a son, a son, a son, a son, a son. Or your football team, how many people are? 6, is it? Ah, the 6th one, so you want a son. I want to form a football team. Then if you want 6 sons, half is 1 out of 2 to the power, 1 over 2 to the power of 6. So the chance of getting sons that way is 1 out of 2 to the power of 6, which is 1 out of 64. getting sons all the way. Alright? So I'd like to tell you, if we use more probabilities and we will master this thing as we get to more difficult examples. And stay on, hang on my dear, till we move on to the next part of it. But first, look through this example which clearly tells you what's the difference between getting one head, one tail, or a head tail. Alright? Take care, have a good day, rest and come back to me.